Okay, let's take a look at how we do a challenge problem for a mass spring oscillator. So in this problem, we have a 1.5 kilogram mass, and it's oscillating on a spring. And the motion equation with respect to time of the spring, x as a function of time, is 0.95 cosine of 4.5 t. And we want to know the maximum speed of the mass. So, okay, lots going on here. One, to find max speed, let's just write down what we're given, I guess. 1.5 kilograms, x of t, 0.95 cosine of 4.5 t, and I'm going to find V max. Well, let me interpret my position as a function of time equation for an oscillator. What I know is my maximum amplitude is the coefficient outside my cosine function. So 0.95 meters will be my maximum amplitude. I also know that 4.5, right, is either 2 pi times the frequency of oscillation or 2 pi over the period. So that's helpful in that I can use that value to try to find the relationship between, I could use the relationship between period and the k value in mass if that's a way I need to go for my solving. So that's something that can help me out. All right, well, let's first work backwards and see, how do I find max speed? Well, I know max speed occurs at equilibrium. So I'm going to reach max speed at a position of 0, okay? So I'm going to say, well, what is that? Well, when I'm at that, I know that my total energy is all kinetic. So that my total energy at equilibrium in the oscillating spring is 1/2 mv max squared. So if I know the total energy and I know the mass, well, I know the mass, then I can find V max using energy. But that I'm still kind of stuck. How do I find the total energy then? Well, let's look at the other extreme position where I know the energy is all spring. 1/2 Ka squared at maximum amplitude will be the total energy when the speed is 0 and my kinetic energy is 0. Therefore, all my energy is spring potential. So now I know A, but I don't have K. Well, here's where breaking down this function can help me, because I know there's a relationship between K mass and the frequency of a mass spring oscillator. So maybe by using this to figure out the frequency, then I can find K, know my total energy, and find V max. So I think I've got a plan. So let's say the period, easier to use period or frequency, doesn't matter. Let's use frequency. I know the frequency of my mass spring oscillator is going to be 1/2 pi square root of K over M. Okay? So from this expression, let me work this over here to the side. 4.5 is 2 pi times the frequency. So if I divide by 2 pi, I divide by 2 pi, I have an expression for the frequency is 4.5 over 2 pi. So I'm going to substitute that in here. 4.5 over 2 pi equals 1/2 pi square root of K over M. And the 2 pi's will cancel out. So I get, let's see, I'm going to get an expression for K. So 4.5 equals square root of K over M. So I square both sides, get rid of that, and multiply by M. I get K equals the mass times 4.5 squared. Okay? All right. So let's use that then to find my total energy. So at maximum amplitude, 1/2. Now my expression for K is mass times 4.5 squared times my maximum amplitude of 0.95 squared. Now let's express this out to make it a little simpler. So I know My mass is 1.5 kilograms times 4.5 squared. That's 0.95 meters squared. Gives me a total energy of 13.7 joules. Okay, now let's use that to go back and find my max speed. So if I multiply both sides by 2, divide by m, and then square root it, I'd get that Vmax equals square root of 2 times the total energy over the mass. 2 times 13.7 joules over 1.5 kilograms. Max. So 13.7 times 2 divided by 1.5. Square root of the answer, I get 4.3 meters per second. Okay. Now again, to recap, the challenge in that was interpreting the position time function, where this is a and this is 2 pi f or 2 pi over t. And once I was able to figure that out, then I think you could see through the couple of steps how I can go about finding Vmax.